major, and I'm the team lead for the Wearable Electrolyte Monitor project. And so kind of like the issue that this project is trying to address is that electrolyte imbalance is something that can be pretty severe, but it's kind of hard to diagnose without a definite test. And these tests require blood or urine, and then the urine test is kind of like a pH strip, so it's not really that accurate. So a lot of times electrolyte imbalance is either not diagnosed or misdiagnosed as something else, like dehydration in the flu, which can be an issue when you're drinking water to deal with lack of electrolytes or something like that. And then there's certain conditions like kidney disease and pancreatitis, which can lead to a chronic imbalance, which requires people to have their electrolytes be monitored pretty regularly. But because there's not really a great way to do this, it kind of makes it harder for them in everyday life. And so the goal of this project is to create a wearable device that can frequently and non-invasively monitor common blood electrolyte levels. So right now we're just going to focus on sodium and potassium because those are some of the most impactful and well-studied electrolytes. And then we want to provide numeric measurements and measure in around 15-minute intervals so you can get a pretty quick measurement. And the concept is kind of similar to a glucose monitoring watch. A lot of the research we've done has been based on research done to monitor blood glucose levels. So that's kind of like the idea we're going for. And so this project's a year old, so we do have a lot of research from the past year. So basically where we're at right now is that we want to integrate an ion sensing electrode, which is kind of the same concept that a pH monitor uses, just for our specific ion, and then an iontophoresis device. And iontophoresis is a process where you can drive ions either through, or you can drive ions through a membrane via electrical current between two electrodes. And as you can see in the diagram in the top right, a lot of common applications are with drug delivery, so using the current to deliver a drug external to the skin to your bloodstream, but we're actually going to be trying to do reverse iontophoresis, where we bring blood electrolyte to the surface of your skin for measurement, and that's where the ion sensing electrode comes in. And a lot of how we kind of came to this design concept was looking at previous studies on measuring glucose and lactic acid level in the bloodstream. And where we're at right now is kind of just figuring out how we're actually going to design this, and then figure out like sort of the biosignals related and how we can, program our device and measure the blood electrolytes meaningfully. And there's like a lot of kind of technical information that I don't really want to get into right now, but feel free to contact me because I'd love to talk more about it. And then as far as timelines, this fall quarter, we're just kind of going to be doing a little bit more research, trying to get everyone caught up with the project, and then creating a really thorough plan for our winter and spring quarters, where we'll hopefully be doing more intense like visualization and modeling of our project. I'm not really expecting to be able to have access to really any physical lab equipment, even though I do have some materials at home. So we're kind of going to focus on having everything be in a virtual format. And that will be part of our report at the end of fall quarter. And then winter quarter, I want to start a more detailed modeling and simulation of the skin as a membrane and then our device interacting with it, and then start trying to program the equipment that we would use for testing. And then maybe do some preliminary testing with a membrane and pure ionic solutions, because we already have those, if possible. And then spring quarter, by the end of the year, I kind of want to develop a really solid plan for lab work that could be performed. And this would be physical lab work that could be performed based on our research and models. If anyone would like to take what we've done, and when, labs are open, kind of apply that, and then put together a final report, because we do have some sponsors related to the project. So we kind of want to report on what we've done so far, and kind of demonstrate proof of concept. And then as a member of our team, What we're kind of focusing on field-wise is biochemistry, electrochemistry, if you're into like signal systems, and then there's, you know, elements of mechanical design and then material selection and fabrication. So if you're interested in any of those things, like there is a place in this project for you. And then depending on how many people join, I'm probably going to split the team into subgroups. That way people can sort of focus on one aspect of the project. And then reach out directly if you would like to lead a subgroup, but I'll also probably do some structuring right after we figure out who's on the team. And then more experienced team members may be expected to help, you know, transfer their skills and teach younger members, but only if they have time. So I'll be asking people and kind of just figuring out who's willing to do that. And then as far as expectations, each week I want to have, you know, a 30-minute to an hour meeting update. That way everyone can be on the same page. We all know what each group is doing. And then have like an optional time where we work for an hour to 2 hours on the task for that week. And that way, if you're really busy that week, you can kind of skip that guided work time. But if you need help, you can stick around and get a lot of focus help on what you're working on. And then the independent workload will probably be around an hour to 2.5 hours, possibly more towards the end of the quarter, but I'll try to make sure that I'm not putting too much work on you. And I want to like communicate really well with my team so I know what people's responsibilities are and I'm not delegating too much work to one group. And that's pretty much it. Does anyone have any questions?